Determine the absolute maximum and absolute minimum values of the function e to the x minus x to the e over the interval from 0 to e. Okay, so we're just looking from 0 to e, absolute max, absolute min. This shouldn't be too much of a struggle. Let's take a look here. So first we'll copy down our function, e to the x minus x to the e, and we should take the derivative, right? And so we're working with a closed interval, so we will need to check f at 0 and f at e, but we also might need to check at any critical points within that interval. So the derivative here, so the derivative e to the x, and then power rule here, so we can get e, x to the e minus 1. And so, okay, critical points. So critical points are, when is this 0? And when is this undefined? Now, of course, for the undefined, it also has to be where f is defined, right? Because if both values are undefined, then, well, you're just not talking about values in the domain, so it doesn't make sense to talk about f being a max or min if there is no f there. So, okay, when is this undefined? And e to the x is defined everywhere. X to the e minus 1. Now, since e is irrational, we can confidently say, all right, x to the, so e minus 1 would also be irrational, x to the e minus 1 is only defined for values bigger than or equal to 0. But that's the same for x to the e. So this part here is defined everywhere where this part up here is defined. So there's not going to be any issues, and certainly there's not going to be any undefined but in the interval 0 to e, which is where we're really looking. So undefined is not an option, but it is still something we should consider, right? You should stop and consider that. Okay? All right. So, but when might it be equal to 0? What can we do? Well, I think the first thing I'd do, take out a factor of e. Now that shifts over the exponential function to the right, but what it does is it also reduces this down to just a single power of x expression. We can divide everything by e. So really, we're saying, well, okay, the first derivative is going to be equal to 0 when e to the x minus 1 is equal to x to the e minus 1. That would be another way of writing this. Okay. And having this as just a single power of x, I can sort of visualize what's going on, which can be nice and handy. So as I was saying, the exponential, with the x minus 1, we've just shifted this over by 1. So what used to go through, pass through 0, 1, now passes through 1, 1, for example. Okay? What used to pass through 2e squared will go through 3e squared. Okay? So that's just shifted over. And what's going on with the x to the e minus 1? Sorry, I misspoke there. Well, that's just a power of x. Now, since the power here is bigger than 1, this is going to look roughly like sort of kind of a half of a parabola, not exactly, but it should grow something like that. Now, the exponential bit here, exponentials always grow faster than polynomials. So as we keep going, that's going to go up higher, but this is going to slow. And so there should be 2 points where they cross. Okay? Now, of course, this is just a rough sketch. It's not exact, but if I can find 2 points where left-hand side and right-hand side are equal, I'd be satisfied. So let's see what we can do. As I've already said, plugging in 1, you'll get 1 minus 1, so that'll be e to the 0, which is 1. And x equals 1, 1 to the anything is 1. So it looks like x equals 1 is going to be a critical value. Are there any others? Is there really a second one over here? It's also possible, I'll just sketch it over here, it is also possible that the exponential, and I mean, obviously they do cross once, but it might be possible for them to sort of touch, kiss it just a moment and touch there and be tangent to one another. So it is possible 1, 1 is the only one. But let's see if we can stop and think. I definitely don't want to sort of go fumbling for a calculator or anything like that, because with the e there, it's not going to be nice numbers to try and approximate or anything like that. But let's try and think, are there other nice values here? And yeah, with the minus 1 here and the minus 1 here, the x and the e just swap places. So if you let x equal e, you'll get e to the e minus 1, and then on the other side, e to the e minus 1. So yeah, that's our other critical point. And again, this should just be the 2. So To summarize, we've got two critical points, 1 and e. Now we need to throw out any critical points that aren't in our closed interval, but remember our closed interval, the one that we're considering for this question, is 0 to e, so it doesn't matter that e is sort of being doubled up. So all that's left to do is calculate f at 0, f at 1, and f at e. So e to the 0 minus 0 to the e, plugging it back into the original function, you get 1 minus 0. So that's 1. That's currently the leader. That's both the absolute max and absolute min as far as we can tell right now, but we do have, of course, these other values to check. So e to the 1 minus 1 to the e. So that's going to be e minus 1. E is about 2 points. I mean, I'm not going to write in equals, but we can approximate it, 2.718. So this is about 1.718, and we do that, no need to grab a calculator or anything like that, just some basic knowledge of e, but we can tell, okay, that's bigger than 1. So currently 1 is my absolute minimum, and e minus 1, which is the actual value here, is my absolute maximum. But there's one more value to check, so e to the x, e to the e, minus x to the e, so e to the e again. Oh, they cancel out, it's 0. So we can see, 0 is going to be my absolute minimum. It's the smallest value, and e minus 1 is my absolute maximum value for this function over just the interval 0 to e. Obviously, maybe it gets bigger or smaller beyond e. We don't know, but we're not interested in that. We're just looking from 0 to e. So we can go back and give just a quick little summary. So absolute maximum value is e minus 1, and the absolute minimum value of this function, again, just on this interval, is 0. And we're all done.